Everyone, so now we are going to discuss about the Eigrp packet. If you remember, in our OSPF also we learned the packets, similar like that concept, same concept, similar concept we have here in the Eigrp also. So we need to remember the packets also here. If anyone asks you in interview about the Eigrp packets, you can easily define them and what packet is doing what work, as we discussed before. So here what we can say, we have the hello packet used to identify the neighbor. They will send the periodic multicast. Every timer they will send this one. Every 5 seconds they will send the hello packets. And we have the update. They are going to use this one if we have any update, like any link go down or any new link come up. They will use the update packet to send the update. And the acknowledgement, when we receive the update, we will acknowledge that one. And we have the query packet. We use this one if if we have any network down in our route, like if I have the router R1, imagine this network go down, so I will query to other routers that I don't have the 1.1.1, is there anyone have the 1.1.1? I will send the query packet to get that information. If anyone know that information, they will reply with the reply packets. So this one we need to remember, like we have the 5 packets in the Eigrp. First packet, we use the hello packet used for neighbor discovery. As soon as the hello packet send and receive, Eigrp router will form the neighborship. Same like we do in the OSPF. And here they are using the multicast address 224.0.0.10. If you remember, there we are using the 5, 6 like that, but here we are using the 10 for Eigrp. This is important in interview. Sometimes they will ask you, so we need to remember multicast address used by Eigrp is 224.0.0.10 for sending the hello packets every 5 seconds. And update packets contain the routing information for the destination. Eigrp unicast the update packet to the newly discovered neighbor. So whenever we have two router, when they form the neighborship and they are going to upgrade the route, they will use this update packet to send the update. Okay, so they are using this multicast address to send that update packets. And then we have the query. Query is nothing but just now what we discussed, same thing. We have the query, that is whenever we have any route down, anything, any route fail in the network, we will use the query packet to get the information about that route. Then same thing, we have the reply packet is nothing but the other guy who know the information about that query, he is going to reply, and at last we will acknowledge that one. How we can check? We can write show IP Eigrp traffic, and we will get this whatever traffic is going for the in the network, like that router, how many packets he sent for hello packets, how many update packets he send and receive. This one is for send. If you see, this is send / receive. So this is a send, this is a receive, this is a send, this is a receive. Same thing we can check with this command. So let's see this one, how we can check. First we need to configure the Eigrp, and we can write this command to check that information, show IP Eigrp traffic. And also we can use the Wireshark to get that packets also. So this way we have the packets, same like before we discussed for the OSPF. Hello we have, update we have, acknowledgement, and like query also we have. So we need to remember this packets name and then what packet is doing what. So let's do a small lab, so we will have the idea for this one. So let me close this. I will close this one, and we will develop the new lab. Let me close the Wireshark here. Just now I open. Now let's see here if we have. Let me create new lab. So Eigrp lab for packets, or anything we can write. Eigrp lab, basic lab. In basic lab we can verify the packets, basic lab. So what we will do, we will take two router. This lab we can do in GNS3 or EVNG, no problem, anywhere we can do. So I will take, this is a R and here is a 2 router we need, And if you want to add the interface, you can add the fast Ethernet, whatever. We have fast Ethernet and Ethernet, only two interface available here. Okay, so I take this two router, we can connect and we can test. So I connected this two router. Let's give the IP schema here. I will write here IP schema 192.168.12.0/24, and here if you want to increase this font size, we can increase and make the bold, and here, and then this is the IP schema. Let me start the router also here. So router 1 and router 2 started. I will take the console of this router and console of this router also. Double click, you will get the console of this router also. It will take some time. Meanwhile, we can create one loopback also here. So I will put this is a one loopback here. We can give loopback 0 and then 2.2.2.2. So we can start the configuration. Let me take the notepad to do this one. Eigrp lab for checking packets, Eigrp packets. Same thing as we do before, configuration will be same. R1 configuration. In the for lab purpose, we can do very easy configuration. I will show you that one. First of all, let me assign the IP address, fast Ethernet 0x0 IP address 192.168.12.1 255.255.255.255.0, and then we write no shut, and then router Eigrp1 network 0.0.0. So all interface he will advertise. Whatever interface is up and having the IP address, they will enable the OSPF in that interface. But don't do this in the production network. This is for lab purpose only. Production network, same thing as we do. No auto summary, and we will write the network ID. We will follow that approach. Okay, so here R2 and this should be 2, and we will add one loopback, interface loopback 0, IP address 2.2.2.2 255.0.0.0. So this is the configuration. Now we can copy and paste this configuration in the router 1. Here we will write no, and also here we will write the no. Now we can copy and paste the configuration here. Let me paste the configuration here in the R1. So now configuration is good. I can capture the packet, right click and go here, capture, and capture that interface like this. It will capture and it will show us the packets. I will write here EIGRP, okay, and select this one and click this one. So you will see EIGRP. This guy, that is 192.168.12.1, is sending the hello packets, and he is sending to the multicast address 224.0.0.10. and if you see, this is a Eigrp packet. We are using the version 5, opcode is 5. This is hello packet, and this is the flags. No flag is set, sequence, and we don't have acknowledgement anything. Autonomous system, we are using 1, and whatever the parameter, we are using only K1 and K3. If you remember, for the metric calculation, as we told, we will use the K1 and K3. So this is K1, K3, and software version, whatever is default version, that is 3.0 we are using, and the length of the packet is 8, release is 5.0, TLB version is 3. So main important thing is this is a hello packet, and we are using K1, K2 only. We are using autonomous system is 1. So now we can see only one hello packet is going on. Only the router 1, 192.168.12.1 is sending the hello packet on the multicast. Other router is not enabled the Eigrp. So what we will do, we will copy and we will paste for the other router also. So I will copy from here. This is a R2, and if you see, this is okay, configuration is okay. We will go in the console of R2 and we will paste here this one. We will paste here, and after that, if you observe here in the Wireshark, After hello packets you will have the hello packets from different also. If you see, this is a R1 is sending hello, this is a R2 is sending hello. Okay, both are sending on the multicast address. After that, this guy is sending the update. If you see, updates are sending in the unicast. As we told, hello packets will go on the multicast, but update will go on the unicast. So if you see, this is a 192.168.12.1. 12.1 is sending to, if you see this one, 12.1 is sending to 12.2. What he is sending? He is sending the update. And then after that 12.2 will send to 12.1. They will send them also update. Then they will acknowledge. So the same thing packets they will send and they will update. If we go here, this is the update packet, and whatever the update they have, they will send. They are using the autonomous system one, and we don't have virtual router ID. We don't have acknowledgement in this one. So here, what we can say here, hello packets will send on the multicast address, that is 224.0.0.10, but the update packets send on the unicast. Unicast means only direct 1-to-1. So 192.168 12.1 is sending to 12.2, and 12.2 is sending to 12.1. So they will send hello packets and they will send the update and they will acknowledge, and at last they will again send the hello packets. And if you want to check in the here in the interface, we can check also. How we can check? The same thing, the command just now what we discussed, show IP EIGRP traffic, like this, show IP EIGRP traffic. With this command we can check. If you see here, this is a traffic, we can check here what we are getting. Hello, send and receive 50 I send. Okay, because this guy, the R1, this is the R1 first came in the network, because we configure EIGRP in the R1 first. In R2 we did not configure, at last we configure. That's why this R1 sent the 50 packets, but he received only 24, because later this guy have the EIGRP, so he also starts sending that one. So this one we can say an update. The R1 sent the 3 update, R1 sent 3 update, he received 2 updates. So this guy sent 3 time update. Update means it is not 3 time, means it is not necessary the 3 different update. Maybe sometime we have the packet size is big, they will break the packets and they will send. Okay, so they are sending the 3 time, they send the update 3 packets and they receive 2 time. And query nothing, because we did not make any route down, and reply also nothing. So now if you want to look the query packet, what we can do, we can go in the R2 and we can make this loop back as done. Why I want to make loop back as done, let me show you. If you see here, let me show here this one, because this is a R1, this is R2. In R2 we have this loop back. So if I make this loop back as done, then this guy is going to send the query packet to this one saying that I don't have the 2.2.2, you know the address of 2.2.2. So let's do and check this guy will send or not. So I will go in the R2 and I will write here interface loopback 0 shut, loopback 0, and I will write shutdown. So interface loopback 0, I will write here shut. Okay, and if you see here in the query, you will have here the query packets also. Let's see here what we have at last. Here we will get the query packet here. Let's see, still they are sending the hello. Yeah, here if you see, this is a query packet. Okay, 192.168.12.2 is asking, they send the multicast address, they are asking I lose the network, anyone know this one? So if anyone know that one, they will reply. But still you can see here 12.1 reply. What he reply? He received the query only. Let me select that one minute, let me make this up. So here if you see here, this is a query packet 12.2 sent by using the multicast address. Okay, this is a query packet. If you see, here is the query, and sequence number is 3. Router, virtual router, we are not using virtual router. Autonomous system is this one. And what he is requesting, he is saying router ID 2.2.2 is sending, and he is saying destination 2.0.0 is not available, this one. So let's see if what the other guy 12.1 reply. he don't have that information. This is the 12.1. 12. Let me source is to 192.168.12.1. he is sending to 192.168.12.2. so to router 1 is sending to router 2 also, that he also don't have that route. Nothing is available about that one. And if we see here, after that they have the acknowledgement and they have the hello packets only. So now if I bring back that router, let me go and bring back, I will write here no shut, and then we will see, we will have the update also. R2 is going to send the update to R1 and R1 will reply to him. If we see here, yeah, this one, this guy, that is 12.12.1, this one first, this guy update 12.2 send the update. Okay, and then after that 12.1 send some update in the multicast address, because he received that information, so he is just sending I received that update 2.2. is available with the R2. And now what we can do, we can go here in the R2 and we can verify. In the R2 we can verify. Let me go here, and now we can run the same command. If you see here, before we did not have the query, so now this is a query. We did not send the query. R1 did not send. R2 send that one. So R1 received the query. This is the send. Send means this one, first one, and receive means this one. So with this one, what we can say, R1 is not send any query, but he received the query, and R1 reply that one. One time he replies saying that I don't have that information. Okay, so this is the hello packets of Eigrp. So we need to remember this one. In interview they will ask you, so we need to remember hello, update, acknowledge, query, reply. Hello to discover the neighbor, update to share the routes, acknowledgement to why we use acknowledgement, when we receive any update we will acknowledge I received that update, whatever update you send I received that one. And this guy will say query, if the route go down he will update and he will query that my route is missing. Example, R2 lose one route, he will update saying that I don't have this route, and after that he will query, is there anyone know about this route, and if anyone know, they can reply. So this packet we need to remember, and with this command we can verify that one. Okay, so now after that let me stop this.